unless you can be really, really sure it's true. Is this not on? What's the problem here? Yes?
I want to ask another question about the comparison of the chemicals.
The capacitor combinations.
That's the question 6. I use each formula, but
Yeah.
I'm trying to find out the answer.
Oh no?
Yeah.
Okay, so I do this one first then. So before I start, if you look at the combination of capacitors, I'm going to do number 6. So on this page, you're on the combination of capacitors. I'm going to do number 6. Right. So, Louise, we have here capacitor, 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 like this, and then we have battery. Okay, and this is a 9 volt. This is 2 micro, 3 micro, 6 micro, 4 micro. Find the equivalent. Okay, the total capacitance, the charge on each capacitor, and the potential. Okay, so first one is the total. So we have to add these together first, the top ones, and then these together. So let's see, 1 over C equals 1 over 3 micro plus, this is A, plus 1 over 6 micro. That is a half. No, sorry, it's a half. 1 over 2.
Yeah.
So that means C at the top is 2 micro, and then at the bottom 1 over C equals 1 over 2 micro plus 1 over 4 micro, which is 3 over 4 micro. So the C at the bottom is 4 over 3 micro. Then I have to add the top one with the bottom one. And because they're in parallel, I just add them together straight. So then the C here is 2 micro plus 4 over 3 micro, which is 10 over 3? Is it? Yeah.
10 over 3 is 3.3.
Yeah, 3.33 microfarads.
Maybe I'm at 1.
Maybe.
Yes, because I add 1 over 3 plus 1 over 2.
These add together, yeah. And then these add together, and then they add together after. B.
I think you can do it either way, can't you? Because I did it the other way and I still got 3.
Okay. I would not be so confident doing it that way, but if it works, it works.
It was 3 plus 2 is 1 over 5, and then 6 plus 4 is 1 over 10.
In my head, though, I always feel like series should be before parallel, but maybe that's just me. Maybe it doesn't have to be that way. If you said you got the same answer, then you got the same answer.
I'm just 3 over 10.
Okay. The charge on each capacitor. The charge now. Now this one's a little bit tricky. First thing I need to do. Can I scroll down a little bit? Yeah. So what I'll do first is I'll put the two of these together. So it's like this, one here, and it's like one here. And we said the top is 2, and then the bottom is 4 over 3. So this one here is 2 micro. So the charge here is, what's it, CV, isn't it?
Yeah, 2 times 90.
Yeah, 2 times 90 times 10 to the minus 6. So that's 180 microcoulombs. Yeah, and that's the answer for this one and for this one. Because remember, when they're in series, it should be the same charge. And you can do the same thing down at the bottom. What is it? 4/3. So this is 4/3 micro. So Q equals CV, which is 4/3 times 90 times 10 to the minus 6. So that goes in there 30 times, 120 microcoulombs. Voltage next. So you know that, voltage next. So that 90 volts here that I was using, that 90 volts is for both of them. If I put a voltmeter here, this is 90 volts. But they want the voltage on each of them. So we have Q equals CV, so V equals Q/C. So if I just draw what I have here, there's 1, there's 2, there's 3, there's 4. Okay, what's the charge on the first one? It's 180, isn't it? So here is 180 micro, 180 micro, 120 micro, 120 micro, and what's the C on each of them? 3 micro. Now this is coulombs, 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 coulombs. 3 microfarads, 6 microfarads, 2 microfarads, and 4 microfarads. So the voltages, you have Q equals CV, so V equals Q/C. So voltage 1 is 180 micro over 3 micro, which is 60 volts. Voltage 2 is the same, 180, oh no it's not, 180 micro over 6 micro, which is 120 volts. No it's not, 30 volts, sorry. What must the total be anyways between the two? What must the total be? Total voltage? 90, so of course it should be 30. V3 is 2 microfarads over 120 microfarads. Is that right? Oh sorry, because I wrote it upside down on the bottom. 120 micro over 2 micro, which is 60 volts. So then this one here should be, it should be then 30 as well, shouldn't it? 120 micro over 4 micro, 30 volts. Now that's just a coincidence that it's also 60-30 at the bottom. And the reason I think because it's the 60-30 is if you notice this is 3 and this is 6. This is 2 and this one is 4. And I think because the proportion is the same, it makes the same 60-30, 60-30. But I'm saying it's just an accident that it's 60-30 and 60-30 for both. Just an accident, okay? It's not normally like that. So we have here, if you want to draw it in, here to here is 60 volts, here to here is 30 volts, here to here is 60 volts, and then here to here is 30 volts.
Capacitors are in parallel with those who are equal to each other.
When they are in parallel, like the total on the top is 90 and the total at the bottom is 90, that's for sure. But what I'm saying, Hugo, is that the fact that they split 60-30 both is an accident. No, but you're right, the total should be 90 and it should be 90 because here is 90 that gets split. So that's not an accident. Okay. Is that okay, Louise?
Maybe I need to practice again.
Yeah. Well, look, there's another one there that's like it. Same type as this, yeah.
Okay.
Yeah, it's the same idea as this one
I have
here.
the question, what's the P20, is the page?
Oh, no, sorry, that's the picture number. I cut the picture number out, but this picture is P26.19, so don't worry about that. Yeah, it's just a number for the picture.
Okay. Thank you.
Like here, this is picture 2623, okay? It's because I just took it from a book. Okay, so this is okay then? Yeah? This is the type of question you could get in section A of the exam. Yeah, well I mean usually section B, but it's not so long. So I think it could be in section A as well. Okay? Right, let's have a look at Kirchhoff now. Right, so just have a look at question 1. So we have resistor, battery, resistor, oh, and another battery. And the battery is 4 volts, 12 volts, and the resistor is 1 ohm, 3 ohms, 5 ohms, 1 ohm, 8. So the question is calculate the current, find the energy delivered by each battery, find the energy delivered to each resistor. Okay, well first we find the current. Right, so what we do first is, let's start with the big battery. So we'll call this one here I1, and what goes into the battery is also I1. So we have I1, but then here it changes because it splits. Now here, this can be I2, into the battery can be I2, along here is I2, along here is I2 as well. So all of this is I2. But when I1 and I2 come together, they make a new current, I3. What's the current here? We don't care, because there's nothing in this circuit from here to here. So we don't care what's there. But it would be I1 actually, yeah. Because I1 was just there. Right, so firstly, Kirchhoff's junction rule, and the junction is here. So we have I1 plus I2 minus I3 equals 0. Firstly. Okay? So did you have that, Louise?
Yeah.
Yep. And Young, did you have this? You had this one, yeah? Okay. Right, so now we need to do our loops. So Louise, tell me, what loop did you take?
Okay, we can use the I1.
Yeah, where did you start?
So, 12.
You started at the 12, and you used this one here. So you tell me what equation you got. So you had 12, yeah?
Minus
Yeah.
minus 3.
So you start out minus
1
I1, yeah?
minus 3 I1.
Yeah.
And then go to the minus 8.
Oh, you went this way, yeah? Okay, minus 8
I3
I3.
equals 0.
Very good. So that's right. Okay. And then what did you do next?
You can use the...
Oh yeah, sorry, I can simplify this a bit, because this is 12 minus 4I1 minus 8I3 equals 0, so I can put them together. Alright, what loop did you do next then, Louise?
Next one is the 4.
You started with the 4, yeah? Okay, so you had 4.
Minus.
Yeah.
1I2 minus
Yeah.
5I2.
Yeah.
And minus 8I2.
Yeah. So that's fine also. Yeah. So that's 4 minus 6I2 minus 8I3 equals 0. So that's right and that's right. So good job. So let me just write them together again. So I have I1 plus I2 minus I3 equals 0. I have 4I1 plus 8I3 equals 12. And then I have 6I2 plus 8I3 equals 4. I just take them over to the right. Right, now before we solve this, we need to think about what we're going to do. So for example, what I think I will do is I'll multiply, hang on, let me think, yeah, I'll multiply this one by 12, this one by 3, and this one by 2. Now if I do that, I get 12I1, oh no, sorry, I don't have I1 there, sorry. What do I have? Do I have I2? Oh yeah, I'll just multiply this by 4, and then I can put these together, and what can I cancel? I can cancel I1. This leaves me with I2 and I3. But what does this one have? I2 and I3. So I think this is a good idea. We'll do it this way. Okay, so I get now 4I1 plus 4I2 minus 4I3 equals 0. And I have 4I1 plus 8I3 equals 12. And I have, well, I'll just leave this one for the moment. So if I minus them, I get 4I2 minus 12I3 equals minus 12. Now I'll take this one down with it. So I have 6I2 plus 8I3 equals 4. For fun, let's use matrix method. Yeah? So here I get I2, I3 equals 4 minus 12. Oh, actually, before I do that, I could divide this by 4 and divide this by 2, just to make it a little smaller. So I have here I2 minus 3I3 equals minus 3, and then 3I2 plus 4I3 equals 2. So this would be 1 minus 3, 3, 4, inverse, minus 3, 2. Which is 1 over 4 plus 9, 13. 4, 1, 3, minus 3, minus 3, 2. That's 1 over 13, minus 12 plus 6, minus 6, 9 plus 2, 11. Yeah, so that is minus 6 over 13 and 11 over 13 for I2 and I3. But don't forget here, I1 plus I2 minus I3 equals 0. So you can have I1 here. You can find I1 because I1 plus I2 minus I3 equals 0. So this means you have I1 equals I3 minus I2, which equals 11 over 13 minus 6 over 13, which is 17 over 13. So I1 is 17 over 13 amps. I2 is minus 6 over 13 amps. And then I3 is 11 over 13 amps. Now I2 is negative. That just means on my diagram, I2 is negative, so it actually means it's going down instead of going up. And the reason for this is because this battery is so big, when the current reaches here, it actually pushes the I2 down. So that's why it's negative. Now, we'll see if that's right. Yeah, it is. I have them as fractions. Did you convert them as decimals?
Yeah.
And they match up?
Yeah.
Fantastic. It's not finished yet, but that's the start.
Really long.
They are. But, I mean, in the exam, this question would be...
Like the first one was...
Section B, yes. Huh?
The first one was really long.
Yeah. If this was in the exam, it would be between 6 and 9 marks. So it's a long one to do.
It's popular for exam.
It is. It's at least 50% of the time in the exam. At least 50%, yeah. Okay, so now the next part of that question. Oh, so Louise, what went wrong?
I'm wrong in unit. I forget to move. I don't know can move the 12 and other line
Move the 12.
and 4.
Oh, okay. Here.
Yes, I switch to minus 4 and other one I minus 12.
Should be okay though.
Okay.
Yeah.
Because I equal is 0, not 12.
Yeah.
Should be okay.
Okay?
It should be.
Yeah, it should be okay. So there must be some other problem. It's okay. But you know, it's okay now. Yeah? Okay. Now the second part is find the energy. Now what's the formula for energy for electricity or for work? Yeah. Yeah. But does it give you the T?
It does, yeah. 2 minutes.
2 minutes, okay. So if you remember, work or energy is IVT. Now what's the first one? The first battery, where's it gone? That's I1. Okay, what's I1?
1.
Where is it? 17 over 13. And what's the voltage of the battery? 12, isn't it? 12 volt battery, yeah? Yeah? Something wrong?
Yeah, it's not asking for the value.
Oh, sorry, it's talking about the resistors. So sorry. So for the resistors...
Wait, no, this is for the overall. This is for the next question, sorry. Oh, yeah, it is.
You know, say B, find the energy by each battery.
Yeah, it is, so
It's okay. IVT. So that is 17 over 13 times 12 times 2 minutes. 120 seconds. What's that, please? 1886.4 joules. Okay. And then for the second battery, IVT, is it I2?
Yeah, I2.
Yeah. Now, the minus is actually interesting there. Minus 6 over 13. What's next?
4.
4 and 120. And what do you get?
Minus
221 joules. Now, did they do the minus at the back?
Yeah.
Good, good. They went for 222. Did they?
2. Oh, it's 2.
Okay. My answer is more accurate because I kept my fraction where I had a decimal for the current. That's why I think. So somebody tell me, what does it mean if the second battery has minus 221 joules? What's this? What do you think the meaning of the minus 221 is? Any ideas? Yeah, but give me simple English, like, what does it mean is what?
It's charging.
Yeah, it's charging. So, that first battery is 1886.4 joules. That means the first battery gives that much energy. But the second battery is minus 221 joules. In fact, that means the second battery takes that energy. So as you said, it's like the second battery is charging up. So the first battery is actually doing all the work, and the second battery is actually taking some of the work, is charging up. That's why it's minus. Okay. Find the total amount of energy transformed into internal energy in the resistors. Okay, so now, how much energy does each resistor use? Okay. So what formula to use there? Let me think. Could we use the same one?
Yeah.
You could almost use the same one. We have work equals IBT, but don't forget you have V equals IOR. So if I put that in, I got work equals I squared or T, which is perfect because we know the I and the or and the T. So let's go with the first resistor. First resistor is I1 squared multiply 1 multiply 120. What did I say I1 was? What number did I have for I1?
1.3.
What I have is a
17
over 13, okay. So that's 17 over 13 squared times 120, whatever that is. Number 2 is still I1 squared times 3 times 120, so that would be 17 over 13 squared times 360. W3 is going to be I2 squared times 5 times 120. What did I say I2 was?
Minus 6
It was minus 6 over 13, was it? Times 600. W4 is I2 squared times 1 times 120. Yeah, 120. What's left? One more?
8 times
I3, is it? I3 times 8 times 120. That is, what's I3?
I3 is
11 over 13, okay. 11 over 13 squared, 940, 60.
How to know the time?
It's given in the question.
Oh.
The question says it's for 2 minutes.
For the 2 minutes, and then you
Make it seconds. Yeah, 120 seconds is, the time is 120 seconds.
It's a lot, but
Yeah.
how about the two?
Yeah.
360.
Oh yeah, in my head I just do 3 multiply 120, that's all, yeah. I don't have a calculator to do this piece.
Okay.
That's why I stopped. Now let's use our calculator. So, whoops.
705.932.
Just give me 3 significant figures. What is it? 206 joules, okay.
618.
Okay.
128.
Okay.
25.6.
25.6. Okay, and then the last one?
687.
687 joules. I'd like you to add all of these together. Tell me what you get. Add them all together. Tell me what you get. Well, they ask you to do that too. All right, we're on the same wavelength. So, 1,665 joules. Yeah. So, this is right, 1665. So, what I'm saying is, all the resistors together use 1,665 joules of energy. Where did the resistors get this energy from? From where? From the 12 volt and 4 volt battery. So, if you look at your two batteries, can you add these together, please? Add these. And what do you get? Oh, very good, yeah. Should be the same. Is it the same?
Yes.
Nearly. Yeah. So this means the energy provided by the battery must equal the energy used by the resistors. What is the name of this rule in physics that we did in mechanics? Conservation of energy. That the energy cannot be made or destroyed, but the energy just changes from one form into another form. Yeah? Alright. Now, this is my plan. For number 3, I will draw the diagram, I will write the formulas, but you will solve the formulas. Okay? So let's have a look at 3. Yes.
Can you use it for instead of the...
Yeah.
And solve it as well?
No, 4 and 7.
4 and 7?
Yeah.
Okay. 3. Only because it's really important topic, okay? No problem. Okay, so the number 3 here. I won't draw the ammeter, okay? I just want to draw the circuit. I won't draw the ammeter or voltmeter. So we have resistor, and then we have battery, then we have resistor, then we have another resistor, and another battery, and then finally resistor here. Okay, so the resistors are, let's see, 6 ohms, 5 ohms, 10 ohms, and 6 ohms. And the voltages are 6 volts, 4.5 volts. Right. First one is actually maybe I'll do it in a different color. I1. And here, I1. And here, I1. Then here I'll call this one I2. This one here, I2. Now, I1, I2, and whatever's down here, when they all come together, they'll make a new current up the top here, which I'll call I3. I3, I3, and I3. But then down here, they split. Some goes this way and some continues down. So I think I should call this one here I4, and then here I4.
How about the middle?
Here? Don't know. And it's okay, I don't need to know, because if you look here, there's nothing in here anyways, it's empty, so it's not important. Like, here, it's empty, so it's not important. So in fact, Louise, what you could do, you could even take this and then put them together. You know, so like you pull it down. Can you use your imagination here? You take this and then put it together. It's not important because this here is empty and it's empty. So we don't care. And I don't know what it is. Okay, so we will use our junction. Which junction to use? Let's see. Oh, which junction to use? Which junction to use? This junction. This big junction here.
Oh yes, because
You can put them together. What's going into this junction? What's going in? I1 and I2. So you have I1 plus I2 is going in. Oh, and I4. What's coming out of the junction? I3. Okay, Abraham, you give me one loop. Who? You give me one loop. And Louise, you give me one loop. So Abraham first, give me a loop. Where do you want to start? Start at 6, okay, go ahead. 6. Yep. I3. So that's a tree, yeah. Equals? Yeah, okay. Very good. You had an easy one. Alright, who did I say was next? Who, wasn't it?
me.
You want to go next? Alright, you go next, Louise. What, you give me a loop.
4.5.
Yeah, 4.5, yeah.
Minus 5.
Yeah.
I2.
Yeah.
And minus.
Yeah. Minus what?
It's down or up?
It doesn't matter, you can go down or up.
Really?
Yes, really, yes, it's your choice, yeah.
Okay. Minus
Yeah.
6 I4.
Yes, now it's plus.
Plus, yes.
You know why it's plus?
Because
It's going the wrong way. It's going backwards. It's not going this way, it's going the other way, yeah. Go on, okay? Equals 0, okay. Now, who? Give me one.
Okay, everything's okay.
Which one are you giving me? Where will I start?
4.5.
Okay, 4.5.
25 minus 5
No, go on, minus 5 I2.
Minus 5 I2.
Yeah.
And
Yes?
minus 6 I3.
6 I3. Oh, you're going up to the top.
Yeah.
Great. Okay. 6 I3. So you're going this way, along here, up here, and then what's next? Equals 0. So actually, yeah, you had a short one too. You have many choices here, many choices. So these are the 4 equations. You solve it now. Go ahead, solve. So let me just write them together for you. You have I1 plus I2 minus I3 plus I4 equals 0. and you have 10I1 plus 6I3 equals 6, and then you have 5I2 plus 6I3 equals 4.5. Then you have 5I2 minus 6I4 equals 4.5 also.
What the first equation is not I1. It's I1.
Oh, sorry, that's my mistake. It should be I1, of course. Yeah? Alright, so here you go. 4 equations and 4 unknowns. I1, I2, I3, I4. So I'll give you, let me see, how long do you need to solve this? 5 minutes? 5 minutes? Okay, 5 minutes to solve this. Go ahead. How are we doing? No good? No, shaky. So if this was in the exam, this would be 9 marks, 9%. One more minute. No? No good?
I'm getting something. Or two.
Right.
Wait.
Right, no, you nearly have it.
Yeah.
Right or wrong?
Yeah.
Who? Don't be shy. Did you get it right or wrong?
No.
Abraham? No. Louise?
I get to choose, but I don't know whether or wrong.
Wrong answers?
I don't know because I have to choose.
Oh, sorry. And young? How did you do? No. So, if you look up, first thing I'll do is I'll just get my computer program to solve it, so we know what the answers are. So, can you read out the first equation? What's the first equation? I1, yep, plus I2. Actually, let me write it in words. I1 plus I2 minus I3 plus I4 equals 0. Okay, what's the next one then? 10I1? Is it? 10I1, yeah? Plus 6I3 equals 6. Like this? Okay, what's next? 5I2 plus 6i3
Equals 1.5.
plus 4.5. Okay?
5i2
Yep.
minus 6i4.
6i4. Alright. So, if I get the right answers here, it means I have the right equations, because the computer does not make a mistake. Yeah. No, not 0, no, don't worry. Let's just go with 3 numbers. Right, so let's just check the answers here.
Then round up properly.
3. 0 point, oh, the question only asked you for I3, I think, was it? Yeah, but you can see it matches up with one of the answers. 0.395, roughly. So, this means I know that the equations are right, okay? But how do we solve it? Using pen and paper. Yes, how do we do that? So what I'll do first is I'll swap these. So I have, look, 10i1 plus 6i3 equals 6, and i1 plus i2 minus i3 plus i4 equals 0. 5i2 plus 6i3 equals 4.5, and 5i2 minus 6i4 equals 4.5. Now the reason I did that, sorry, that's an I1. Do I have an I1 in the first equation? Yes. Do I have an I2 here in the second? Yes. Do I have an I3 in the third? Yeah. And do I have an I4 in the fourth? If I have this, then I can use something we haven't used in a while. I'm going to use the Gaussian method from maths class. Do you remember Gaussian method? So this is 10, 0, 6, 0, 6. 1, 1, minus 1, 1, 0. 0, 5, 6, 0, 4.5. And 0, 5, 0, minus 6, 1.5. I feel this is the best way to do it for big problems.
Can
So,
I use another?
of course you can. But for me, I feel this is easiest for me to do. But you can use another method. But I hope you like this one. So what I need to do first is try and get, if you remember, 0, 0, 0, 0, 0, and 0. Now this is great because look, I already have 3 zeros, so I'm halfway finished. What I'll do first is I'll multiply this one by minus 10, or 10, it doesn't matter. So now I get 10, 0, 6, 0, 6, minus 10, minus 10, 10, minus 10, 0, 0, 5, 6, 0, 4.5, 0, 5, 0, minus 6, 4.5, and then what we do is we add them together. So 10, 0, 6, 0, 6, 0, minus 10, 16, minus 10, 6, 0, 5, 6, 0, 4.5, 0, 5, 0, minus 6, 4.5. Then what I'll do is I'll multiply this by 2 and multiply this by 2. So now I have 10, 0, 6, 0, 6, 0, minus 10, 16, minus 10, 6, 0, 10, 12, 0, 9, 0, 10, 0, minus 12, 9. Then what I do is I take this one and add it as well as the fourth one. So now you get 10, 0, 6, 0, 6, 0, minus 10, 16, minus 10, 6. Now adding these two, 0, 0, 28, minus 10, 15. Now I'm adding these two, 0, 0, 16, minus 22, 15. Look, we're nearly finished. We just need to get this one here, 0. So let me see. Maybe if I just be lazy and do 16 here and 28 here. So if you help me with your calculators, please. 10, 0, 6, 0, 6. 0, minus 10, 16, minus 10, 6. 0, 0. Say again? 448. Minus 160, and then here, please. What is it? Oh no, I'm being lazy, I'm not even thinking about the number. Just give me this one, 240. Like this? Yeah. And then this one here is 0, 0, 448. Let's actually make this a minus here. So minus. So what's this next one? 660. With a plus because it's minus and minus now. 616. With a plus because minus and minus. And then this one here will be a minus. What's this one then? 420. Okay, so then we add 10, 0, 6, 0, 6. 0, minus 10, 16, minus 10, 6. 0, 0, 448, minus 160, 240. 0, 0, 0, and if you add these, 4, 5, 6, and here? 180. Great. Finished really, because now you can say 4, 5, 6, I4 equals minus 180. So what does I4 equal if I divide it? As a decimal, please? Oh, nice. Because if I look at my answer here, what's I4? Minus 0.394. Alright, now if I look at this one, you have 448I3 minus 160I4 equals 240. But you know what the I4 is. So you get I3 equals 240 plus 160 minus 0.395 all over 448, which is... Did you really check it, or you just have confidence that I did it right? Just check it, because maybe I made a mistake. For I3? And you get the idea. Then you do the same thing here. They just want I3 in the question, so we're actually finished. We have I3.
And then question B.
Yeah, what's B? Yeah, actually that one I could have done at the start. It's a little bit sneaky. If I go all the way back to my picture, Okay, so what's the voltage in this battery? 4.5. You see here?
Yeah.
So here, this is 4.5. Now, if I put a voltmeter here to here, what's the voltage in this battery? 6. So the voltmeter tells me the difference in the voltage between two places. So what's the difference between these two locations? The difference between this and this?
1.5.
Yeah, and is the answer 1.5?
Just minus.
Yeah. That's all. So like if you look here, you know, if this one has 6 volts and this one here has 10 volts, and I put a voltmeter between them, then this will say 4 volts. I don't worry about the plus or the minus, yeah. That's all. What about, what about if I put a voltmeter here, what would it say? 10. And if I put it here, it would say 6. And if I put it between them, it would say 4. Voltmeter tells you the difference. Now if you look here, here is 10 and here is 10. I mean, there's no difference, it's just 10. But this is 10 and this is 6. Oh, actually, no, that wouldn't say 10. I'm sorry. No, it would actually say 0 and 0. There's no difference, yeah. Let me just do that again because that was important. Hey, look. This is 10 volts, and let's say this is 2 volts. So if I put a voltmeter here, it would say 8. If I put one here, it would say 0. And if I put one here, it would say 0. Now, if I put a resistor here of OR, what would the voltmeter say? It wouldn't be 0 anymore, because the voltage changes when it goes through the resistor. In fact, you can calculate it using V equals IR. So that's what the V is there. And likewise, if I put a OR here, then it'll be V equals IR. Now, what about if I put a battery here? If I put a 6 volt battery here, what would this say? Yeah, it would say 6. You might say, well, hang on. What about the 10 here? Well, if you think about it, what's happening is, here is 10 and here is 6. Here would be 10, but then when it gets to this battery, here would be 16. Because you have a 6 and a 10 working together. But the voltmeter only tells you the difference. The difference between 10 and 16 is 6. Okay. Right, what did you say you wanted next?
If you didn't have a valve in that picture, if you didn't have how would you measure the 10 then?
You would have to put a voltmeter around that battery. Yeah, or do something else, but basically you would need some kind of second measurement. In other words, 1 voltmeter couldn't be enough to tell you the 2 different voltages for 2 different batteries in a circuit. Yeah. Which did you say? 4 and 7. Okay, so if I look at 4 looks like this. Battery, resistor, battery, and then there's a diagonal one here, 4 OR, and then a 3 OR. Okay. Now, the question tells you what the E and the OR is. It tells you that the E is 250 and the OR is 1000. Okay. Right. I1. No, I should start with the bigger one. I1, I1, I1. And then here, I2, I2, I2. And then they come together here, but then they split. I3, I4. I3, I4. Yeah. Right. Junction rule. I actually have two junctions. I have this junction and I have this junction. We'll go this time. Which junction do you want to use? Yeah, well, which one do you want to use? Top or bottom? Top. So what's going into the junction? Yeah, I1 plus I2. And what's coming out? I3 and I4. Sorry, it's not very clear, but this is an I4 here. Equals 0. Young, do you think you can give me a loop? You can give me a loop, do you think? Yeah, okay. So where do you want to start? 2E or E? 2E, okay, so go. 2E. Yeah, minus 2 or I1, yeah. This one here, or I2, yeah. Plus or minus, plus or minus. Very good, plus. Plus, what's it? Or I2, yeah. Okay, go on. Very good, minus E, yeah? Yeah, equals 0. Good job. Right, we'll go back to the back. Ibrahim, give me another loop. If you can see it, okay?
E minus.
So where are we starting? Here, is it? E. Yeah. Plus or minus?
Minus.
Yeah.
Minus
Minus 4 or I3 equals 0. Okay. Who, since this is your question, you can give me one of the loops. So which loop do you want to give me? 2E, yeah?
2 minus I1 T1.
Yeah? Yeah?
And minus 3 on I4.
3 or I4 equals 0. Now you know the E and the OR, so this is actually I1 plus I2 minus I3 minus I4 equals 0. This is 500 minus 2000 I1 plus, I need more space. Yes, of course, divide by 500. 500 minus 1000 I1 plus, no, 2000 plus 1000 I2 minus 250 equals 0. So we could divide by 250. This one here, 250 minus 1000 I2 minus 4000 I3 equals 0. 500 minus 2000 I1 plus, nope, minus 3000 I4 equals 0. So I will divide by 250. So this is I1 plus I2 minus I3 minus I4 equals 0. This is 2 minus 8 I1 plus 4I2 minus 1 equals 0. This is 1 minus 4I2 minus 16I3 equals 0. 2 minus 8I1 minus 12I4 equals 0. Going to the right again. I1 plus I2 minus I3 minus I4 equals 0. 8I1 minus 4I2 equals 1. 4I2 plus 16I3 equals 1. Oh, I can actually divide this one by 2 as well. So 4I1 plus 6I4 equals 1. No, 2, 1, yeah. So, would you be happy if I just used the computer program to solve this? Because in my opinion, I would like to use the block again. I like using the block for when I have 4 or more. I prefer to use this block. Okay? But we'll just use the computer program for now. Can you read those equations? Did you write these down?
Yes.
Yeah. So let me see. Read them to me, please. What's the first one? I1 plus I2 minus I3 minus I4. Okay. What's next?
8I1.
Sorry. Say that again, do. 8I1, yeah.
Minus 4I2.
Yeah, whoops. Equals 1. Okay, what's next then?
4I2.
4I2
plus 16I3.
16I3 equals 1 as well. And finally,
4I1.
4I1
plus 6I4.
6I4 equals 1. Right. Solve system 4 equations on line number 3, 4, 5 and 6. And we'll do our decimals. Right, so there you go. There's I1, I2, I3 and I4. What do they want in the question though?
Current in the wire.
The bottom from A to E, is it? They want to know what the current is. Can you just write down those 4 answers, please? I1 is 0.13. I2 is 0.01. I3 is 0.06 and I4 is 0.08 amps. You got those 4 answers? Yeah?
Yes.
Okay. So the question is asking you, what is the current here at the bottom? So if you look at this wire at the side, what current is going into this wire? What's going into it? I3 and what else is going in? I4, very good. And what's coming out?
I1,
I1 and I2. Oh, but hang on. I4 is going in and I3 is going in, but they're both going in opposite directions. So what I'll do instead is, let's look at this piece here. So how big is this I3 that's going in? What's I3? 0.06. And what's the I2? 0.01. So think about it like this. I say at the end 6 go in and 1 comes out. 0.06 go in and 0.01 go out. So in total, how much goes in at the end? Yeah, 0.05. Now, how much should come out this side? It should be 0.05 also, because if 0.05 go in, then that's how much should come out. So let's look at the other side. What's it? I1 and I4. Okay, so I1 goes in and I4 goes out. How big is I1?
I4 goes in.
Sorry, I4 goes in, I1 goes out. How big is I4? 0.08. And how big is I1? 0.13. So which is bigger, going in or going out? Going out. So how much goes out? 0.13 in total, minus 0.08 total? Yeah, which is actually the same as this side. So in total we have 0.05 amps going from the left in and out on the right. So what was the problem with this? What made it difficult for you?
Not very clear to find out the loop at the beginning.
At the beginning, yeah. Now, number 7. Did you say number 7? What's nice about number 7, which I'll show you here, is number 7, they actually tell you what loops to take. So for A, you see here, Louise?
Yeah.
They say take the upper loop. So that means this loop up here. Then B is the lower loop. So that's this one here. C is the junction on the left. So that's that junction there. D is the junction, D, they then say solve. E, so in other words what they're doing is they're telling you all the steps. So they say A, loop, B, loop, C, junction, D, solve the junction for I3. E, use the answer found in part D, cancel I3, found in part B. So in other words, they're telling you all the steps to do it. Now you don't have to do it that way, but it's recommended. And finally, they want what is the answer for I2 and I3. In other words, they want you to solve it.
What's on the back? The unit is C.
Unit is C? For which part?
You just take your body.
For what number? 7.
Yes, 7.
C. What? Maybe that's the wrong answer, I think. So I'll tell you what. I will give you a few minutes to do 7. Then I'll just get the computer program to solve it, and you can check your answer. So I'd like everybody to try number 7. Number 7. Yeah, but still it's a difficult one. I'll put the answers up on the computer program. Sorry, I just realised for this lesson now, I had the video paused. So in fact I didn't record this lesson. So I hope you understood everything. Okay. Oh well.